For the cylinder method, what we're going to actually do here is run two different samples, the same soil, and both of these soils are from just below the surface, In one case we had a little bit of mulch on top and a cover crop, and we actually took it just below that area. And then the other soil, or the other sample, is from the onions over here, and that actually has been tilled up more recently. We would expect that the soil that's been less disturbed is going to have more organic matter, it's going to have more roots, going to have more stability, and the onions, which have been recently tilled, would be less. Other than that, the soils are exactly the same. So let's go ahead and get these soils in their strainers here. You can see them in their strainers here. The size may not be exactly what's indicated, but we wanted to make sure, as for the clods, may not be what's indicated in your guide, but I think for the purposes of understanding what's going on and hopefully we'll see how this works, this will make a big difference. Now, one thing I do want to throw the caveat in here is as I said in another video, or another part of this video, is that we are in the desert. We really don't generate a lot of organic matter. It's very hard for us to increase our organic matter in the soils. We have probably less than 0.5% in this particular, either one of these particular PEDs. So that's not very much. A lot of you will have a lot more than that. I don't know what kind of results we'll see, but it'll be interesting. But you do see that we've got a very well-developed system over here, which has been well taken care of. It's been undisturbed as much as possible. And then we have a system that's more typical of annual tilling, where you're growing vegetables and things like that. So these are the systems. These are what people are doing. Let's just see if we can see a difference in the aggregate stability of these two different systems. So we're going to go ahead and put these in. We're going to start our timer up here, and we're going to let it run for 5 minutes. What we want to do is we want to see what's going to happen, not only when we put the clods into the water column, but we want to wait for 5 minutes, and we want to see how they break down. So as we put them in, water is going to enter into those dry PEDs, those dry clods, and that pressure is going to actually start to maybe break those apart. We expect that to happen as air rushes out and water rushes in. What we're hoping is that the organic matter and the stability of these soils will actually hold those together for a long period of time. This would simulate, say, a rain event or irrigation falling on these soils, and them being able to continue to maintain their shape, their aggregation, if you will. And then over a period of time of rainfall, precipitation, irrigation, whatever it is, that these soils would be able to continue to take in water, infiltrate water without breaking down and sealing themselves on the surface. That's the hope. We need 5 minutes to do that. So we'll go ahead and we'll put these in, and then we'll come back in 5 minutes and we'll show you the results of that. So here we go. So the one on the left here, this is actually the one that's been from the onion field. So we're going to put that one in first, and you can see that right away we're losing some material on that. So let's take the next one, which is actually from the cover crop area that's been sitting for a while, and let's see what happens on that one there. So you can see right off the bat there's quite a bit of difference. We're losing material on both, but if you look at the bottom of those cylinders, you can see that after just a few seconds, we have quite a difference. So let's go ahead and set our timer, and we'll just see what happens with these two different scenarios in about 5 minutes. Okay, so 5 minutes has passed for our water stable aggregate soil health field test, and you can see by the bottoms of these two cylinders that on the right there we have a very water stable aggregate. There's a little bit of material that came off, but that came off right in the very beginning. And if you look over here on the left, you can see there's quite a bit of material on the bottom. Now, you have to realize that we have not agitated these at all. We have not simulated raindrop impact or sprinkler impact whatsoever. We've just let them sit quietly. But if you look at the surface of these two, as you're seeing right now, you can see that the one on the left has pretty much puddled. That's if we gave that a shake or two, just a little bit of a shake, I'm pretty sure that would probably all fall through. And you can see as we move that, how that just begins to sort of collapse and fall down. Now, if you ignore the fact that there's a rock in this clod up there, you can see that this particular one is much more stable. It looks pretty much exactly as it did when we put it in. And if we move it around a little bit, you can see that material is coming off of it, but look how much clearer that actually is. It's coming off in actual discrete chunks. It doesn't really cloud the water up. It's almost as if you can see those particles individually as we move through there. So that's an indication that even though it's breaking apart, those aggregates are still sticking together pretty well. They're much smaller, but they're not cloudy like we've got over here in this particular side as we move that. So quite a bit more stable than we have over here, which you can just see quite a bit more debris coming down. Now, I want to just sort of remind everybody that we're doing this in the desert. We're doing this in soils that have minimal organic matter to start with, virtually no organic matter. These are both cropping systems or both agricultural systems, but you can see that even in this kind of arid environment, if you take care of your soils and you focus on this by doing certain things, is you can actually still get, even though it may not even be measurable, but it's obviously visual, the difference between a soil that hasn't been able to be managed for agricultural aggregate stability because of whatever you might be growing there, and a soil that's just been left alone and has had cover crops put on it, and how much even if the organic matter content is minimal between these two, there's enough of a difference that we have stability in one and obvious lack of stability in the other one. Okay, so this particular soil field health assessment is going to deal with soil structure, and I'm going to read about the importance of soil structure right straight from the guide. It says soil structure affects water infiltration, impacting flooding and gas exchange, plant rooting or plant rooting depth, nutrient cycling, plant condition and health, and soil organism habitat. Poor plant condition as a result of compacted soil may have an impact on animal health as well. So that pretty much covers everything that we're going to be doing in the field there. So looking at soil structure gives you a very good understanding, or you're able to infer what's going on with the soil, and you can actually maybe make a lot of assessments about other conditions in the soil just by looking at soil structure. So we've got a pit dug here. It doesn't, and again, this is a pit that you could just dig in a couple of minutes. There's not really, you don't have to go very deep. We're really looking at the root zone, and in this case we've gone down just about a foot on that, and so you can see some variety here. What we're really looking for is what does this actually look like? And so you've got a knife. You can use anything that would work. This is a great tool for that. And what you kind of want to do is you just kind of want to look. This is our surface. It's actually a lot of organic material there. But just below our surface, what does it do when I actually poke it with a knife? First, I'm just going to sort of poke it and look at it. I'm just going to work my way down and do that. Is there any different? Right here, I can kind of feel like there's a resistance. This feels pretty soft, and I run a knife up through that. You can kind of see that I'm just barely holding the knife and just running it up through there. And you can see that I'm making a nice little groove there. If I come down here a little bit farther, you can see that I'm not really getting the same kind of material falling off. So it looks to me like we have a break right through here in structure. Now, soil scientists would probably call this a horizon break as well. But let's just go ahead and say that based on that, we've got two different things going on up here. The next thing I would do is put your hand down in the hole and just take some of this off with your knife again, and just have a look and see what it looks like. What do we actually have here? You can see that we've got some structure. I've got some larger material, some larger clods. I've got some that maybe are even a little bit smaller, like here and there. This would be a good example probably of a granular or a slightly subangular blocky, if you want to get into the technical soil science term of this. And see, I'm kind of banging on that just a little bit, and you can still see I'm breaking up the larger aggregates into smaller ones. But the point is that you can see material in through here on the edge of this knife, and not all of that is sand grains. Some of that material is just really small dirt clods or really small aggregates as well. So this soil is a sandy loam soil. There's not a whole lot of clay in it, but you can see that we've definitely still got some structure in this upper layers. Now let's go down a little bit further and see what we've got in the lower layers here. Now, I took this out, and you might say, well, that looks pretty good. And it doesn't look bad at all. here you can see we've still got, and we're only down about 7 or 8 inches here. You can see we've still got some structure. But look what happens when I break some of this up. Do you see that it looks, a lot of this material is now individual sand grains, and when I kind of like dug it out of the side there, we still have some structure. See, I'm just seeing how well those things stay together when I knock on it. It looks like a rock there. But what we can see is there's still some pretty good structure in through there. It's not bad. It's very small, and it may not be used to what you guys are seeing in your areas. But what I do want to point out is that you can actually see more individual sand grains or rock fragments in this one than you could in the other one. That's kind of to be expected, because we know that organic materials and glues and things like that kind of help drive structure. And what we're going to show you probably in another segment here in this particular hole is the difference in where the root zones are. There's actually roots. We'll focus on this in a bit, but there's roots above here, and there's really hardly any roots below that. And that may actually have quite a bit to do with what your structure looks like. So in both of these cases, we have, maybe some people would call this a granular structure. Soil scientists might get a little bit more technical and call this a weak, fine, subangular, blocky structure. But nevertheless, we can see structure throughout this particular profile. I don't see any evidence of compaction, and even though you can run your knife up through here and you can feel a little bit more resistance, you can still see that this is not, there's nothing wrong with this soil here as far as that will impede roots or impede water and air movement into this particular soil. So a lot of times you can actually look right into this hole and you'll be able to see if there's some sort of restrictive layer. But if you're not comfortable with that, just run your knife like I'm doing through here and just see how, is there any resistance to me sort of poking this with the knife? And you can kind of see that in this zone here, there's definitely nothing. But even down through here, you can see there's really, it takes a little bit more force to push it, but still there's really no force that's necessary. If you've got that going on through there, then you know that you don't have any problems with your soil structure. So we're going to look at soil roots, or in this case with the same particular pit, as it has yielded us not only good soil roots but a lot of other things as well. But we're going to turn your attention to the soil roots here in this, or the plant roots in this soil pit. I didn't say that correctly before. Hopefully in the shadows you can actually see this. I'm going to use the knife to point to this zone again. This is that soft zone that we showed before when we were doing soil structure. But look at the abundance of these fine roots all the way from literally the soil surface, which is right below this kind of mulchy layer, all the way down through here. And it's harder to see. It's harder to see, but I can see roots even down into this layer. Quite a few roots, not nearly as many as this. This seems to be the majority of where the fine roots are in this soil. And we're about 5 feet away from a tree, and we're right in the middle of a cover crop area. So I suspect that what we're really seeing here is not the tree roots, but we're seeing actually the result of having a cover crop in this area. So these fine roots being all the way through the soil, they're not really restricted by anything, it doesn't look like. That to me indicates that this soil is pretty healthy, at least in the zone where we're seeing the roots. So if you notice that the roots are not in a certain particular part of your soil, then that might be an indication that either your water's not getting down through there, and of course that's something that we're always concerned with in our dry, arid Southern California climate, or it might be an indication that you've got something else going on in your soil, like say perhaps a compaction layer. And hopefully you would have done some assessments that would have indicated that's something to look for. And then the fact that the roots weren't growing through that layer would be an additional indication that that's something that needed to be managed, or that was something that was going to be a problem. So I hope you can see all those kind of roots there. What we want to do is we want to also talk about the biological diversity and biopores, which are two more things that are on the soil health assessment checklist. We're not going to really have that here. I mean, biopores, yes, they do exist, but it's going to be hard for us to find that again in our soil. We have a very dry environment, and those are uncommon. It's also going to be more difficult for us to find any kind of biodiversity. Do we not have it at all? Of course we have it. Yeah, all places do, but our life is much smaller because a lot of the things that live in the soil need organic matter, and we just don't have that organic material to drive a lot of that larger visible camera-friendly biodiversity. But what I will say is that when it comes to biological diversity, if you dig a hole just like this and you look through that hole and you're able to pick out, say, 3 different types of organisms, we know that you can see with your naked eye, that's an indication that your soil's pretty darn healthy, and that's kind of what we're looking for. Does that mean that our soil is not healthy because we can't see anything? No. We're considering our environment that we're in as well. And in this environment, the organisms are going to be more specialized, just like humans would be. They're going to be closer to where they're going to get more regular water. So I think that's all we wanted to show you for this particular hole. Okay, we're back from the field now, and hopefully you enjoyed seeing how we do those 11 different indicators for soil health. So I just want to sort of reiterate that you don't need to do all 11 of those indicators each time. The manual will tell you which ones are appropriate for which time of the year as well. So and some of them will be quite obvious. You'll know that even without reading the manual. But feel free to check that manual out, read through it. It's a quick read, it's an easy read, and there's lots of information in it. So depending on the part of the country that you're in or the part of the state that you're in, you may choose not to do some of those indicators. In our case, we had only 2 different cropping systems. We had the onion field, and then we had the orchard with a cover crop on it. Your agricultural system may be totally different, and some of the indicators that you may choose to use might be far more appropriate for your agricultural system. So that's all we've got for this one. Hope you have a super happy, great soil health week. Thank you.